Going to be doing Unit 7, Notes 4. So we are going to be talking about probability and just a review of probability. Now, most of this you have done in years past, probably even in elementary or middle school, but we're just going to kind of give you a reminder of it and also apply it to some more difficult problems because you're going to be needing this throughout the course of the probability unit. So let's take a look at, in general, how we calculate probability. First of all, probability is a measure or an estimation of how likely it is that something is going to happen. So that's what probability means. So how do we measure that, okay? Well, the measurement that we're given is a value between 0 and 1. So if it's a 0% chance, like if it says there's a 0% chance of snow today, it's not going to snow today. But if it says there's a 100% chance it's going to snow today, well, it's going to snow today, or they wouldn't say it's a 100% chance. So the higher the degree of the probability, the more likely the event is going to happen. Now, we usually in this unit, I'm having students write their percentages as decimals. So when we calculate out the probability, we'll actually be writing it as a decimal, but it still means the same thing. So the notation P of A, so if you see that P of A, it's the probability of event A occurring. So you can use that, okay? So let's go ahead and let's take a look at calculating probability. So probability is the number of successes over total outcomes. So you need to figure out how many total things could happen, and that's going to be on the bottom, and then figure out the number of positive things that could happen, and that is going to be on the top. So let's take a look at the probability of rolling a 1. So we're just working with dice here. So first of all, there's 6 numbers on a dice. We know that, okay? So we want to figure out the probability of each of these following things happening. Well, first, the probability of getting a 1. So I need to ask myself how many 1s there are on a dice. Well, that's just 1. There's 1 dice, so that's going to be 1 out of 6. Now again, I told you I usually have students write it as a decimal. So you divide 1 divided by 6 out, and you get 1.167. Take a look at the next one. Probability of rolling a 2 or a 3. Well, the number of successes is going to be 2. So we're going to take 2 and divide it by 6. When you do 2 divided by 6, it's 0.33. Now I chose 2 for the number of successes because there's 2 different options there for me. So now I want to find the probability of rolling an even number. Well, there's 2, 4, and 6. Those are the even numbers on a dice. So that means there's 3 out of 6. So I'm going to write that as a probability. 3 out of 6. When you divide that, you get 0.5. We're taking a look at the next one. Rolling a number less than, or more than 2, sorry. So when it's more than 2, that's going to be 3, 4, 5, and 6. So there's 4 numbers that are more than 2. So that's my successes. So then we're going to do 4 divided by 6, which is going to give me 0.667. Now, I want you to be very, very careful about your rounding on this one. So you're going to take a look at the 4th number. If the 4th number is 5 or greater, round up. If it's 4 or below, round down. So taking a look at the next one, the probability of rolling a prime number. Well, prime numbers are divisible by 1 and themselves, and that's it. 1 is actually not a prime number. 2 is the prime number, 3 is the prime number, and 5 is the prime number. And just as a kind of general heads up, 2 is the only even prime number. Every other prime number from there on out is going to be odd. So there's 3 prime numbers on a dice, so 3 out of 6 is going to give me 0.5. Now, we're going to do some probability with a standard deck of cards. And you know, a lot of students kind of forget just the numbers that go into the card. So it's really important that you write this down. So there's going to be 13 cards in each suit. And the suits are hearts, diamonds, clubs. That is a terrible club. Clubs, there we go, almost, and spades, okay? So then there's 4 cards of each type. So there's 4 kings, 4 queens, and so forth, okay? There's a total of 52 cards in one deck, okay? So then their number of face cards, there's 12 face cards. So face cards are going to be a jack, a king, and a queen. All of those are defined as face cards. So there are 36 numbered cards. Ace is not a numbered card. So an ace is not a numbered card. So the numbered cards are 2 through 9. So there's going to be 9 in each suit times 4 suits is 36. Okay, so that's where that 36 came from. So there are 26 black cards and 26 red cards. Hearts and diamonds are red. Clubs and spades are black. Please excuse my terrible drawing, but hopefully you're kind of it's making sense to you. So let's do some probabilities with card. First of all, the possible outcomes we know for each one is going to be 52. So first things first, we want to find the probability of getting a spade. Well, a spade is one of my suits. So since it's one of my suits, that means there's 13 of them. So the probability is going to be 13 out of 52. Well, when you divide that out, you get a fourth, which makes sense. Each suit is a fourth of the deck. So that's going to be 0.25. Then you want to find the probability of getting an ace, which is a 4. And then we have 4 out of 52. And when you do 4 divided by 52, you get 0.08. Students sometimes forget this and think that an ace is a suit, but an ace is a type of card. So it's like a king, it's like a 4, it's like a queen, it's not a suit. Next, the probability of getting a red card. Well, you remember that a red card is half the deck. So 26 red cards out of the 52. Well, when you divide those out, you end up getting the 0.5. We want to find the probability of getting the jack of clubs. Well, the jack of clubs is actually just one card. It's the card jack in the suit of clubs. So there's only one of those cards. So that's going to be 1 out of 52. So I know you guys all go home on Friday night and play Go Fish. And let's say you really need the jack of clubs and there's an entire deck in there. Yeah, not so likely that that's going to happen. It's actually a 1.9% chance that you actually draw out the card that you need. So that's why card games can be so difficult to play, because the probability is not in your favor. Taking a look at a face card, well, we talked about there being 12 face cards, Jack, King, Queen in each deck, times 4, per suit times 4 suits is 12 per deck. So that's going to be 12 out of 52. And when you divide those out, you get 0.231 as your probability. Okay, so that's dealing with cards. So I suggest you guys have this note sheet out so you can reference card stuff as you're going through these problems. You're going to need this card information for the rest of this unit. So it's really important that you have that written down. Now, let's take a look at complement probabilities. So complement probabilities are if it says not. So maybe it's so when it says not. So when we're looking at a probability of not, what we can do is 1 minus the probability of the event happening. So if we want to find, if it says, what is the probability that A does not occur, we can take 1, which is our 100%, and subtract off the probability that it's not occurring. You could also go through and find the successes of it not occurring and do it regularly as well. But I wanted to kind of expose you to that option just in case you were to find it. Okay? So let's take a look at number 1. It says you have a bag with 3 red marbles, 2 green marbles, and 5 blue marbles. What is the probability of randomly grabbing a blue marble? Well, first thing I need to do is figure out how many total marbles I have. So that's 3 plus 2 plus 5. So that's going to give me 10 total marbles. How many of them are blue? Well, 5 of them are blue. So 5 divided by 10 is going to give me 0.5. So that's my answer for number 1. Let's take a look at number 2. You decide you want to read Harry Potter. There's 7 total Harry Potter books. You go to your bookshelf and randomly pick one of them. What is the probability you do not choose the first book in the series? So here's that not that I'm talking about. So the first book in the series, how many books is that? Well, that's 1 out of the 7. That's going to be the first book. So what I can do is take 1 and subtract off the probability that it is the first book, because that will give me the other probability. Well, 1 can also be written as 7 over 7. Okay, and that makes it easier because when you are adding or subtracting fractions, you have to have the same denominator. So we're going to keep the denominator the same when we add and subtract fractions. 7 minus 1 is going to give me 6. So 6 out of 7 is going to be my final answer for number 2. Okay, so then let's take a look at number 3. It says, that's really small. A bowl contains 2 green, 10 blue, and 8 red stones. If 2 stones are chosen at random, what is the probability that it is not green? Okay, so let's take a look. So we want to find the probability of having not green. So this is another way you can do it. How many are green? Well, 2 of them are green. So we have 2 plus 10, which is 12, plus 8, which is 20. So we have 20 total. So I'm going to do 20 over 20. So I'm going to find the probability of not getting a green. So I'm going to take my 1 and subtract off the probability of getting a green, which is 2 over 20. So the probability of not getting a green is 20 minus 2, which is 18, divided by 20. Now notice that it says what's the probability of 2 stones are chosen at random. So we're going to take this probability and we're going to multiply it by itself twice. So here's the probability that the first one is not, and here's the probability that the second one is also not. Now when you multiply fractions, you're going to multiply across the top. So 18 times 18 is going to give me 36. Oops, not 36, Miss Humber. That's 18 times 2. So that's going to give me 324. And 20 times 20 is going to give me 400. So I'm going to go ahead and divide those two, and I get 0.81. So there's an 81% chance that we're not going to draw a green. So you need to make a doctor's appointment next week. What is the probability that it is on a weekday? So how many days are there in a week? Well, there's 7 days in the week. How many of them are considered a weekday? Well, that's going to be Monday, Tuesday, Wednesday, Thursday, and Friday. So 5 out of the 7 days are considered during the week. So 5 divided by 7 is going to give you 0.714. And this is just a friendly reminder, guys, to watch your rounding. So maybe try and divide some of these fractions out with me to make sure you're rounding correctly. If the fourth number is 5 or greater, you should be rounding up. You can't just cut off the decimal because you feel like it. Let's take a look at number 5. There are 4 male and 6 female puppies in a breed. What is the probability that you will get the female puppy? Well, first we need to figure out our total number of puppies, which is 10, okay? And of those puppies, 6 of them are female. So we're going to take 6 and divide it by 10, and that's going to give me 0.6. Last but not least, let's take a look at this one. A single card is chosen at random from a standard deck of 52 player cards. What is the probability that it is not a diamond? So now, since it's a not, what I'm going to do is I'm going to take 1 and subtract off the probability of getting a diamond. Well, a diamond is one of our suits. So there's 13 diamonds out of 52 total cards. So again, I'm going to write 1 as that fraction of 52 over 52, because that makes it easier to subtract out. So then I have 13 over 52 that I'm subtracting out. Well, 52 minus 13 is going to give me 39. 52 is going to stay the same, remember, when you're adding and subtracting fractions. So then you divide those two out, and you end up getting 0.75. So that concludes your note video for today. Make sure you let me know if you have any questions. Thank you for listening.